Today we will go over section 6.5, which we will go over vectors in R squared as well as R cube. So use of vectors can be applied to a variety of areas. The main area we use them is in coordinates form, which we got familiar with XY plane from the very start of your experience in math. However, we will learn that we are not only restricted to XY, rather we can expand the plane. Before diving into that though, I would like to define a few things. Position vector is just a straight line having one end fixed while other end is attached to a moving point. So such as this one, this end is fixed and this is a moving point. This vector is used to describe the position of the point relative to the body. So why do we use the position vectors? It's because it tells us how far and in which direction a point is with respect to the chosen origin. I also know that for the points I have, they are unique representations of vectors. This uniqueness just means my point is a unique value. It is not restricted to a specific point. Every vector we have on the xy plane will be unique. When we have a point in component form, meaning it has both the x and y components, x component is represented by A, while the y component is represented by B. So this means that whenever I have a vector like this, I actually have an x component right over here of this vector, which is represented by A, the magnitude of the x component represented by A, and then I have a y component of this vector also, and the magnitude of this component is represented by B. So these make up this vector. Now passing on to what I meant previously by expanding our xy coordinates. XY plane represents things that are two-dimensional, hence why we call it R squared. However, when it comes to representation of 3 dimensions, we cannot use xy as it is not giving enough information. In this case, it is represented by XYZ plane. So you might be asking why z looks like it took a place of y and y took the place of x. Well, that's not really the case. We can use right-handed system for that to understand it better. So if you point your thumb up and locate your fingers as illustrated, xy plane is actually the same, we just add the z-axis to it. So if you think about it, this x right over here is actually this on a paper, and this y is actually right over here, right? And that z-axis is going right through, so that actually represents the 3D that's passing through. If you were to think like, let's say this is a bowl or something, right? xy is, you can think of it for paper, right? On a paper you can represent, because it's easy to represent 2 dimensions. However, whenever you skip to 3 dimensions, you have to have that z-axis. That's why we added it. We need to represent that 3 dimension with something. So if you use the finger point right-handed system, it will make more sense. So how can we use this z-axis? Well, let's look at this example. I have a vector p which has the coordinates a, b, c. This means my x-coordinate is a, y-coordinate is b, and z-coordinate is c. So it just goes like this now, x, y, z. So my coordinates are in that format. Then they use this vector to draw a cube. Now, if I want to define what is the vector that reaches to another corner of my cube, my coordinates change, but it is determinable. For example, for point B, right? If I were to draw a vector reaching to point B, like this, my vector has x and y components. So if you think about it this way, I do have an x component and a y component that makes up this vector. Let me draw it better. So in order to reach this vector, all I do is I draw the x component and I reach it with my y component as well. But I realize it does not have a z component. I never went up in this direction to reach my vector. Now, because it doesn't have a value in z-axis, the value is considered 0 for the place in the coordinates that for Z. Same conditions apply for the point A as well. If I were to draw a vector to the point A, I realize there is no Y component or Z component associated with it. It's a point directly on X. Therefore, I do have a value for X, but the rest for Y and Z, it needs to be 0. So if a question said determine the coordinates of C, D, E, F, I can do that. Let's start with the point C, which is right over here, right? So I will start with the origin and reach out to C. For C, what I realize is it does have the X component to reach over here, and it does have a Z component to reach out to the final point, but it does not have a Y component. I never reached out to Y. Or if you try to imagine it 3D as well, it's just at one of the walls. You can think of it that way. So the coordinates for C would be, I have the X component, so I'll just put A. I have the Z component, but I don't have the Y component. So in the place of Y, I'll put 0, and my Z component is C. Now let's try D, coming from the origin again, and D is this point right over here. And the thing you can realize is as soon as it's on the axis, so let's say for the point D and for point A as well, as soon as it's on the axis, you already know that it involves that axis, but the other ones are 0. So for D, all I have as a vector is this one. It doesn't have any component except Z. So my coordinates for that would be my X is 0, my Y is 0, I only have a Z component, so 0, 0, C. Now trying for E point is right over here, so it will be a vector that's coming like that, and realize that this is also like the one on C, it's on the wall coming from the origin, right? So this one I can have a vector component which is on Y, and I have a vector component Z, right? So it's moving in the Z direction and it's also moving in the Y direction, but I don't have a component for X. It's not moving in this direction. So what I have for E is my X component is 0, the other ones I do have. Lastly, let's try for F. The very first thing I realize already, it's on the Y axis. So this just means the rest of it is 0 and I only have a Y component, right? So what I'm going to do for F is 0 for the X component. I do have my Y component, but I don't have any Z components as well. Now this question is a little bit just advanced than the last one compared to the last one, but definitely doable. In the following diagram, the point T is located in R cube. What are the coordinates of P, Q, R, M, N, and S? So starting with P, right, which is at this point, and I know my origin is right over here, right? So what I'm trying to find is like a vector over here. You can think of it that way. It doesn't want me to draw a vector, it just wants the coordinates. So for P, I know because it's located on the y-axis, the rest of the components are going to be 0. So I will have a 0 point for X, and I will also have a 0 for the Z-axis as well. But I need to figure out what's my Y, what is the value for that. Well, if you look at the T given to us, at this point, my Y component is at 2. And in terms of Y, T and P are on the same level. They're at the same level in terms of Y. They only change in terms of Z and in terms of X. Okay, so I can put the same value given to me, provided to me by the T value, which would be 2. So the P coordinates would be 0, 2, 0. Now passing on to Q, which is right over here. If it helps you, you can draw a vector to see if it has the components or whatnot. Right now I see that it does have a Y component to it right over here, and I see that it does have a Z component that reaches out to Q, but it does not have that X component. So I know already my X component is going to be 0, Now I need to figure out my y and z. I know for y, just like p, because y is not going to change even if it's down. When it's down, the only thing that changes is the z value, okay? So in terms of y, they share these 4 points. So P, S, Q, and T share the same value. So the y value is 2 for me. Now in terms of z, Q and T are on the same level. So that means they also share the z value. Now passing on to R, which is at this point, if I were to draw it, I see that the only point I have is the z-axis. I don't have the x, I don't have the y component. So directly I can say 0 and 0 for the x and y. And I see for z, it is in the same level as t in terms of z. Not for x and y. In terms of z, they are on the same level. So I can use the same value given to me, -2. As for the point M, which is located right over here, you can draw a vector if it helps, right? It only has the x component. So you might be saying, you might be a little bit confused on that. So you can also extend this xyz plane in a way that this here is the -x, okay? So it's the opposite, just as like the positive component of y and negative component of y that we saw on the xy plane. So for z, this is actually -z part, and for y, this extends just like that as -y, okay? So whenever you see for point M, it's located on x, it's just on the negative side of it. In terms of x, I realize M and T are on the same level, and my value is -3, which confirms it is on the negative side anyways. So I'm just going to say my M value is 0, -3 for the x value, and 0 for the others. Lastly, the S value, which is located right over here, if I were to draw a vector, it will look like this. I realized that it does have a y component to reach that, so you can draw the components and reach out to the vectors if it helps. So this is my y component, and I also have the x component, but I don't have the z component. So again, this S shares the same location except z, so I can just use the same x and y coordinates given to me. Now the second portion of the question says draw the vector OT. I know O is right over here and T is there. All you need to do is draw a vector that reaches out to that T. So that passes through the cube. That's it. The point Q, 2, -3, and -5, which is represented right over here, is shown in our cube, and it wants us to write an equation for the xy plane. Now, because it wants the equation for xy plane, I know that xy doesn't have the z-axis. So wherever on xy plane I choose my point 2, z will equal to 0. So the coordinates would be a coordinate for x and y and a 0. So the equation I'm going to choose is z equals to 0. That's it. It's not asking for any fancy equations whatsoever. The second point is write an equation for the plane containing the points P, M, Q, and T. I find out those points on the graph to make it easier on me. So P is here, M is here, Q, T is here, and Q is over here. Okay? Now for these points, I need to figure out a common thing between them. I see that in terms of x, they're not in common because one of them has 0, one of them is 2, one of them is 0, the other one is 2, right? For the z value, I look at 0, 0, but it has -5 for these ones. But in terms of y, all of their y's are the same. So what I can put as an equation is y equals -3. And I can also put the coordinates if it makes better sense to you. So for the first one, it would be x, y, 0. And for this, it would be x, -3, and z. The third question is write a mathematical description of the set points, set of points in rectangle PMQT. So PMQT is the same thing we were looking at part B, which is this part. And when it says write a mathematical description of the set points, we can also re-include this. So we can also retype this, but I will also explain the other descriptions of this or restrictions. One of the restrictions I see is for x, it's either equal to 0 or it's either equals to 2, right? So anything between that counts for the x. So for the x, I can actually put the restriction saying my x is between or equal to 0 and 2. Now I look at z value, the same thing I do, I see 0 and -5 and anything in between because it's asked for the rectangle, right? So it can go down like this. And the restriction I'll put for this is -5, again, equals 2. And for the restriction for z, that would be up to 0. The last part is saying what is the equation of the plane parallel to the xy plane passing through R. So what this means here, first let's find the point which is right over here, right? And it wants me to find the equation of the plane parallel to the xy plane, okay? I know my xy plane is this part, okay? And it needs to be parallel to R. So parallel meaning if I were to draw a plane passing through R, it will look something like this, okay? And on this plane, what I realize is x and y, so that's y and this is x, right? X and y changes because it can, for the dots, you can have different values at any point. However, in terms of the z value, it's all the same because they're all on the same z plane. So in terms of the equation, I can say my z will equal to -5 for that plane. If you have any questions in terms of this video or any problems that you would like us to solve, make sure to go to our website, and on our forum section we will send you the solution to it.